Okay, so yesterday's thing was we looked at nested types further, and we said, okay, as far as a class which is a member of a class is concerned, right? We can have a access specifiers, all four access specifiers, like we can use a private here. Okay, so it is applicable to the type. Okay, so B as a data type can be used only within this scope of the class A. Okay, fine. But as far as interfaces are concerned, everything is always public. Okay, because all members of interface are public, so a nested type in an interface would be a public type. Fine. As far as the access specifiers for members of an interface are concerned, okay, in case of default method and static method, we can even use private. That is from Java 9 onwards. Okay, fine. Otherwise, it's public. There's no protected or default. By default, it would be public. Okay, so members of interface by default always public. Two members from Java 9 are allowed to be private also. So you have to explicitly declare private. Okay, and then yes, we saw this example which was related to the local class. Okay, we can have a nested class, but there the class is a member of a class. Okay, fine. One of the members in a class is a method or a constructor. We have blocks also. So inside a method, constructor, or a block, when we declare a variable, we call it as a local variable. Fine. Just like we can have a local variable, we even can have a local class. Okay, so we can even have a local class. So here is an example like this. We have a class test local class. Okay, and we keep an instance variable called account. Okay, type is account, and we have a method1. Okay, so here we have some local variable, and we have said double x is equal to 0.9, something like this. If it, okay, now yeah, we also saw this concept of a effectively final. This is from Java 8 onwards. uh, it's not necessary to declare a variable to be final. Okay, for it to be, it's like this. You have some local variable. Okay, if you have a local variable, even if it's not declared as final, but you have done initialization only once, you're not reinitializing it, you're not changing the value any other time. Okay, so such a local variable is said to be effectively final. Okay, so will be treated like final at a few places. So it's not necessary to declare it to be final, and there are a few places where only final variables, local variable, are applicable, right? They are usable. Okay, if it's not final, it won't be usable. We'll see, come across such a scenario. So for such variables, we call them as effectively final. So here in our case here, fine, if we look at the whole code, fine, double x is equal to 0.9. We haven't changed the value of x anywhere else, right? So it's going to be remaining the same value. Okay, so we call this as a effectively final variable. Okay, fine. And now if we look at a class, so just like in a method we have local variable, we even have a class definition which is a local class. So this code, which is for a local class here, okay, fine. So this part is nothing but this is a class inside a block. It could be, this is a method block, and it could be a constructor block, or it could be the initializer block, or any other. So any place, then this is known as a local class. Okay, fine. The scope for using a local variable is within that block itself. Similarly, the scope for using a local class is within that block itself. Right? So this class is nothing but a data type and will be known only within the scope where it is declared, right? So here it's only available within method 1 as a data type. It's known only within the method 1. But how we have defined it, we said, oh, it extends from the account class. Okay, it is extending from account class. Okay, fine. And then what we have done is we have overridden the deposit method to in this class definition we have overridden the deposit method. An important thing to note here is if someone will invoke method 1, at that point this class has no effect. There's no effect of this piece of code. If someone invokes method 1, this is not an executable statement. It is for the compiler to create a class file for this. It knows there is a type like this. It has to just create a type definition from this. And it has nothing to do with the invocation of the method. So if someone is invoking a method, this is not participating in that. Okay, so your first statement which is executed is an assignment to a local variable x. Next statement would be this dot account equal to new local class. Okay, yeah. When it says new local class, yes, local class is something which is usable here. Then it has to look in the definition, which is in the class file. And from there it will pick up and call the constructor. Okay, so here I'm assuming you have the proper constructors and other things, right? Okay, and then so this is nothing but creation of the object of the local class. Okay, yeah, this for the time being you can ignore. This is related to effectively final. We'll talk about that final usage of final. So there is something which is applicable here. Same thing will be applicable even to a lambda expression. A similar thing is applicable. So when we come to that, yes. So at this moment, just ignore the lambda expression which we have. Okay, fine. So the statements which we have here are like this. In this method 1, we have a variable x. We have a creation of the local class, and which is assigned to the instance variable account. Okay, fine. What is done in the local class is overriding the deposit method. Okay, next thing what we do is we define a method 2. Okay, fine. Method 2 is simple. Whatever is the instance variable, let me invoke the deposit method on that. Okay, so we're just simply invoking a deposit method. So the question here was, if we have in the main method, someone creates object of test local class and then calls method 1 first, followed by calling the method 2 on that object. Okay, what is the object? If I have said test.method1 and test.method2, when I say test.method1, it is initializing the instance variable. If I am calling test.method2, it is invoking the deposit method on the object. Okay, fine. What is the object? So when I call which deposit method will be used? That was the question first. What is the object in account 1? What is the object in account 1? Here. What is the object in this variable? It's the object of local class, because it's a subclass of account. Yes, it could be placed here. And so account is referring to a local class object. Okay, fine. As far as method 1 is concerned, method 1 has finished. But the object which is of the local class is there with the variable, instance variable account. Fine. This reference, and this will refer to the, and this here will be referring to account, local class. Okay, now the method 2 is about calling the deposit method. Which deposit will be used? So that's whether it will be deposit according to the account class or according to the local class. Method binding done at runtime. It's the object which decides which method will be used. So which method? Local class. So deposit has to work according to local class. Yeah. In this class definition, right, we have variables. And we are making use of this when the method 1 is over. And this method, fine, the class 2, the methods in class, the local class are actually getting used even after the method 1 is over. Okay, so now the other point which we had was whether can we use a local variable like x. Okay, can this local variable x be used inside the local class? Should it be valid? Okay, method 1, if method 1 is over, where is x? Is there any x? It was on the runtime stack. It was part of the frame. Frame is gone. My object of local class is still there because it was created here. Okay, fine. So it's part of the heap, right? Okay, and then someone invokes a method on that, right? So a method like deposit using the variable x. So should this be allowed? Fine. Okay, fine. So fine, it should not be allowed, right? Okay, so what has been done here is we can use a local variable of the enclosing method inside a local class if it is final or effectively final. When I say final, it includes the effectively final case. Okay, Java 8 said it's not necessary to declare final. So the concept of effectively final comes from Java 8. Okay, so see what happens is if you declare final, there is a fixed value to it. It's like a constant. So that constant would be copied by the object. Object of the local class will keep a copy of that constant. So if there is any final or effectively final variable, a copy of that will be maintained with the object. Fine. So only final local variables or effectively final local variables may be used inside a local class. Otherwise not. Okay. And that was the whole point, right? So same thing is also applicable to a lambda expression. If we have a lambda expression, can I use a local variable of the enclosing scope in the lambda expression? Can x be used here? Only if it is final or effectively final. So this rule applies to lambda expression also. Okay. Sorry. Fine. So this was the main point what was discussed yesterday. Okay. And then yeah. So we have, so this was to be clarified about the local class. And see, whatever we talk about local class, an anonymous class may be a local class also, because it's about creating object. When you create an object, you say, oh, I want an object of a type, of a type of so and so, right? So anywhere you can say new account, use a 3-parameter constructor and write a body for it. Give the class definition. Okay, so they are, so if you are doing it inside a method, inside some block, that's a local class. Okay, so anonymous classes may be local classes. So that effectively final thing, right, will be applicable there also. Okay, right, so final or effectively final, variables being used inside a local class.